G'day team, welcome back to another video in linear programming. So today we're going to be looking at solving problems using linear algebra and linear programming. So this is kind of just bringing together all the skills we've practiced over the last few videos, all into a given context. So we have 6 steps for success in these problems. So step 1, we need to define our variables. So that's our x and y values or variables, okay? Step 2, prepare the table like we've been practicing. Step 3, the objective function. So this is what we're trying to minimize or maximize, okay? Typically, it's a cost or profit equation, and that is why in the table we were writing down the cost or profit in our table. Step 4, gather our constraints from the table. Step 5, graph our simplex. And then step 6, find that optimal solution. So I have stolen a little question here from the textbook. So a factory makes gas meters and water meters. Gas meters need 4 gears and 1 dial and are sold for a profit of $20. Water meters need 12 gears and 1 dial and are sold for a profit of $31. There are a total of 60 gears and 9 dials available for production. How many of each meter should be used or produced to maximize profit? So that's the big key here, maximize profit. So step 1 was looking at what variables are what. So I'm going to define gas meters to be X and water meters to be Y. So coming down here, I've got gas meters are X, water meters are Y. They're made from gears, dials, and we have our profit here and our limitations. All right, so we're going to go in and fill in this data. So a gas meter needs 4 gears and 1 dial, makes $20 profit. Water meters need 12 gears, 1 dial, and make $31 profit. Now we only have 60 gears available, and we only have 9 dials. So there's our table done. So step 1 and 2 are done. Step 3 was our objective function. Now this is what we are trying to optimize. Now we're trying to maximize profit. So we look at our profit column here and we list them off like our constraints. So 2x, 20x plus 31y. And we are trying to maximize this. So it's really important that we're stating what we're doing with this function, okay? Now, let's find our constraints. So step 4, easiest ones to get, x and y greater than or equal to 0. Now for gears, we get 4x plus 12y is less than or equal to 60 because we can't have more than 60. And then for dials, x plus y is less than or equal to 9 for the same reason. All right, step 5. We need to graph this. So what we need for graphing linear equations is an x-intercept and a y-intercept, all right? So for both of these, so for this one, x is equal to 15 and y is equal to 5. So make the other one 0, and here x equals 9 and y also equals 9. All right, so I've gone ahead and sort of put in a scale, okay? Really important that we're adding gas meters and water meters to label our axes, all right? Got our origin here. So let's graph our points here. So in pink, I'm going to draw our 4x plus 12y. So x equals 15, y equals 5. So that looks something like this. And this, we need to label our equation. So 4x plus 12y is equal to 60. And in green, I'm going to do the other one, x plus y equals 9. So through 9 and 9, just like that. And we're going to go up here, x plus y equals 9. All right, because our inequalities are below, so they're less than, that means we have to go underneath our lines, but still above the x and the y axis. So my feasible region is all the stuff in there. So I have a vertex here, a vertex here, a vertex here, and a vertex here. So we need to check all 4 to see which one gives me my maximum. So we come down to our little table here, right in our vertices. So I'm going to go back to blue. So we have one at 0, 0. We have one at 9, 0. We have one at about 6.3. We're going to say it's 6.3, but we can check properly on our calculator if need be. And then 0.5. So all we're doing is substituting these values into my equation here. 0 and 0 gives me 0. 20 times 9 is 180. 6, so 20 times 6 is 120, plus 93 is 213. And then 31 times by 5 is 155. So now we need to identify which one gives us the maximum, and this is our maximum profit here. Now, for problem-solving questions, we need to put our answer and solution into words. So I've gone ahead and written this, all right? So to maximize profit, which is what the aim of the problem was to do, to maximize profit, the company should produce 6 gas meters, so 6 lots of X, and 3 water meters, 3 Ys, for a total profit of $213. So stating our full solution there. Hopefully this has been helpful, and we'll see you guys in the next video.